So, first of all, thanks for having me. And is that a little echo?
No, you're okay.
Okay. And for this opportunity to talk and share what I'm doing here in Georgia Tech. So today, I will present a little bit the work that I'm doing here, and I will talk about use of educational data to predict students' performance. I'm a visiting scholar in Georgia Tech until May this year, and I will come back to Brazil, and hopefully I will continue to meet everybody virtually. So here, my advisor is Professor Richard Catabron. We work in the Problem Solve and Educational Technology Lab at the School of Psychology. The agenda for this talk, I divided basically on introduction, just to see what I'm saying, a contextualization, and talk a little bit so the education data mining, and a case of study following 5 steps: data collection, data clean and transformation, feature selection, deep learning models, and evaluation. And I will finally with a brief conclusion. The main point of the research is great repetition. It's an important topic for all educational institutions. Great repetition here, I'm talking about students who keep the same grades more than 1 year. So they didn't achieve at the minimum expected to go to next year, to next grade. And for some psychologists, great repetition has not been seen as a fair strategy because it can cause some problems for the students, like poor peer interactions, aversion to school, behavior problems, and probably youth drop off, aversion to school. In educational institutions, we have many academic and personal data that are stored, and you can explore to find hidden or unknown knowledge. Yeah, I saw one mistake here, but okay, unknown or hidden knowledge for decision making. To predict students' performance using education data set is a topic that has been researched for several years, but there are some limitations. And the basic goal is identify as soon as possible students who need assistance in the course, because we can allow teachers to adopt pedagogical learning actions, avoid the students fail or drop out. In this talk, I will share a case study involving data deep learning models to predict students' performance using different dimensionality reduction methods. For these experiments, we used one data set from Portugal about high school. Now, that's available on the internet, I think, since 2014. Yeah, there is this kind of data set. So, the education data mining. It is based on knowledge discovered in database process. Very known, very many people know this process. Fayad and others defined in 1996, but until now we can use to follow all the steps. That basically we have 5 steps. We are from raw data until the knowledge. And we have selection, pre-process, transformation, data mine, and interpretation and evaluation. Now we did one case study based on all these 5 steps. As I said, the case study is to predict student performance in secondary education using academic and personal data, and based on this KDD process. So basically, let me take care of this. We collect data, we did some clean and transformation, we choose 4 feature selection. The idea is to minimize the amount of features that we have in the data. Present all this data for the deep learning models and see what we have and compare these models. Now, let me explain all these steps that we did. The first one, the phase 1 data collection. This data set is possible to find in this website. As I said, it's from Portugal. We have data from Portuguese schools. Basically, this data, we can find academic records, demographic information, technological resources, social attitudes, family background, and socio-economic status. I brought just a sample to everybody knows better how features that we have in this data set. That is school, age, address, family size, mother's education, father's education, free time, how much time the students have to free, no study. And if I have, for example, if they drink during the week, drink just weekends. So there is 33 features in this data set. The number of the absences. And for the records, academic records, basically we have about the grades. We have the grade, first period grade, and the second grade. For the phase 2, basically data and clean and transformation. I brought just some examples, but we transform nominal to numerical values like internet. Yes or no, we change for 0 or 1. And also we reduced the number of possible values. Like G3 is a target value, target feature, that means pass or fail in the class. 0 to 9 and 10 to 20, because we saw and understand how is the Portuguese system to pass 1 year to another. Now, 0 to 9 means that fail, and 10 to 20 or average or above average. But anyway, he can pass and move to the next grade. The phase 3, we have the selection features, because we had 33, but we use some methods, some algorithms to look all these features and try to see what's the most important. And using information again, we got 17, relief 10 features, Borura 14, and recursive feature elimination just 13. This is the features that it's selected for each algorithm. Some I put in bold, as bold, because they are exactly the same, like the 2 grades and the amount of failures. The phase 4 basically was the deep learning models. Então, then we create 5 deep learning models, the Google Colab, using TensorFlow and Keras libraries. We present personal and data academic, use for neural network to see if pass or fail. And the first layer, we did some changes because sometimes we use 33, sometimes we use 17, the same amount of each algorithm choose. The phase 4, I brought just an evaluation, but just because it's 10 minutes, I don't want to spend too much time this, but I brought just training and for test accuracy. If I use all the features, like 33, the training that I use 80% of the data, we had 100% accuracy. But the most important you need to focus is on test accuracy, just 20%. And in this case, in this study, the Boruta algorithm that choose 14 attributes got the best result, 0.929. And the next slide is basically to see how the accuracy of the Boruta algorithm and over the epochs, as soon as we can see the examples, he will improve over the time. And for the conclusion, for this talk, right, to predict students' performance, you have investigated the use of feature selection algorithms to obtain a model with more accuracy than others. You'd like to see if it's possible to use less features, minimize the amount of data that you need to show for the neural network to try to classify if these students is possible to fail, there is high chance to fail in the future or not. And in this case study, the Boruta help us to find and to classify these students. So I'm looking for other projects that I can collaborate in the future. And my idea just bring and share with you what I'm doing. Let's see.